To find the area of a trapezoid, we're going to use the formula area equals 1/2 times the height times the sum of the two bases, b1 plus b2. So let's go ahead and find the area of these two trapezoids down here first. Then we'll go back and we'll actually attempt the challenge on the second figure and find its perimeter. So starting with area, let's go ahead and it's a matter of just plugging in some numbers into that equation and doing some number crunching. So 1/2 times the height, remember, needs to be always perpendicular to your bases. So the height of this trapezoid is 5.8. And then make sure you include parentheses around the sum of the bases. B1 and B2, it doesn't matter which one's which, just make sure you're adding them together. So 3.6 plus 6. What I would probably do is simplify the parentheses before I reach for my calculator. So I'd say 5.8 times 9.6 once I add those together. You don't need to do that, but I like to do that just so I have a little bit less to type in my calculator. And then finally, now using my calculator to do this, I'm going to say the area is 27.84. If you don't trust me, grab your calculator and check for yourself. Do make sure you include a label though. Area is always squared, so in this case it's meters squared. Alright, and then my next trapezoid, let's start again with its area, then we'll do the perimeter part of it. The area is going to be equal to 1/2 times the height. This time the height is an actual side of the trapezoid. That's because it was perpendicular to the bases. So the height's 4. And then multiply that by the sum of the bases. The bases are 6 and 8. Again, you can type that in just the way it is. I would recommend just simplifying the parentheses first though. So 6 plus 8 gets you 14. And then multiplying 1/2 times 4 times 14, we get an area of 28 square feet. Okay, let's go ahead and try the perimeter for this second figure, just to see why it's a little more challenging. Perimeter means add up the 4 sides, or add up all the sides, which in this case is 4 sides. So I know 3 of them. One side is 6, plus another side that's 4, plus another side that's 8, plus I get that slanted side though, which I don't know. So let's call that x, and we have a way to figure that out, but it is a little more challenging than just plugging numbers into the formula like we just did. So here's what my thinking is going to be. I'm going to go ahead and drop the height straight down on this side over here. So I know that that piece is 4, it's going to match up to the height on the other side. Now this piece down here, since I've dropped that height straight down, I know that that is going to match up to the top, so that gets me a distance of 6 feet right there. So this leftover piece right here must be 2 feet, since I know the entire side on the base is 8. So 6 feet right here plus 2 feet right there gets me the 8 feet total. So hopefully, as you're looking at what we've now created over here, hopefully you know what we're going to be doing to find that missing side. Once again, I have a right triangle, and I will use Pythagorean Theorem to find that third side out. So the two legs are 2 and 4, so let's do 2 squared plus 4 squared, and set it equal to the hypotenuse squared, which in this case is the side of the trapezoid I need to find in order to find its perimeter. So I've got 4 plus 16 needs to be equal to x squared. Simplifying that, I get 20 is equal to x squared, and finally I'll take a square root, and I find out that that side length is about, and let's go ahead and round to 2 decimal places, it's about 4.47 feet. So knowing that side, now I have all 4 sides. Now I'm able to find the perimeter. That's why I mean it was a little bit more of a challenge. It's not super difficult, but it is a little bit more intense than just plugging numbers into an area formula. So let's add up our 4 sides. We said we already had 3 of them. So those 3 that I already knew were 6 for the top, 4 for the side, 8 for the bottom. Make sure you include the entire side on the bottom. And then that missing 4th side that we just found was 4.47 feet. Adding all those values together gets me a perimeter of 22.47 feet. If we're ever given a coordinate grid to take a look at, we can find the area by counting or finding the distance of the sides I need to know. So in this case, we are asked to find the area of this trapezoid. Now, I've gone ahead and already counted the sides I needed. I knew from the previous slide that my area formula was equal to 1/2 times the height times the sum of the two bases, b1 plus b2. And so what I did was I found the bases, and I could find those simply by counting because they were horizontal. Now if these segments we needed to find the length of were slanted, diagonal, I would need to use the distance formula or Pythagorean Theorem. In this case they gave me sides that I could just easily count because they're horizontal and vertical. So I found the two bases, and I noticed too that my graph went by tens, so I counted by tens. So I had a base of 40 and a base of 70. I also need to know the height, which was perpendicular perpendicular to the two bases, so I found that height to be 50. So using those values, I can go ahead and find the area of this park. It's equal to 1/2 times the height, which I counted to be 50, times the sum of the two bases, which is 40 and 70. Once again, I would go ahead and simplify what's in the parentheses first before I reach for my calculator. And then finally, when I did my calculation, I came up with an area of 2,750. And I checked back for my label, and I noticed that this time everything was in meters. It was a 10-meter graph or grid, so I'm going to use meters squared for that. Now, they don't ask me to find perimeter, although I could do that, kind of like we talked about previously. I would need to do a Pythagorean theorem, though, because I cannot count diagonally, so I would need to use Pythagorean theorem to find those two sides. Then I could add up the four sides around the park. But in this case, they just asked for area, so we'll stick with just finding area.